Today we're going to, in our warm-up, review how to look at an exponential equation and take that information, fill out a graph, and then graph it. So taking a look, our form of an exponential equation is always y equals a times b to the x power. Now, our a is always our 0, which is also known as our y-intercept. So just by looking at the formula, we know where we're going to graph it on this line, and we know where our 0 is going to be here. Now we're going to go ahead and take a look at that b. That b is our multiplier. Now, an exponential equation is an equation that gets really, really big, really, really fast, or really, really small, really, really fast. And when we have a line or a linear equation, y equals mx plus b, it's adding or subtracting the same number each time. That's what makes it a straight line with a slope. However, the reason why an exponential function gets really, really big or really, really small, really, really fast is from one number to the next, we're multiplying. So that depends on that multiplier. If that multiplier is greater than 1, then we're going to have an exponential growth. And that means it's going to get bigger over time. If that number is between 0 and 1, that means we're going to have an exponential decay, and it's going to get smaller. So taking a look here, I have a 0 of 50, and my multiplier is 0.4. I also like to add a -1 onto my equation as well. So I immediately can plot my 0. My 0 is 50. Okay, and I can go ahead and put a point at the y-intercept of 50. Then I'm simply going to go 50 times 0.4, and that's going to give me my next number. So I have 50 times, I did divide, so let's make that a times 0.4. And so my next number in my sequence is going to be 20. So I'm going to go ahead and plot 1, 20. Okay, I'm going to continue that. 20 times 0.4 is 8. So I'm going to have 2, 8. Then I'm going to multiply that times 0.4. And I'm going to get 4, 3.2. And that's going to continue. Now I want to also know what's on the left, so I know how steep I'm going to make my exponential curve. So I'm going to go back to my 0, 50, and I'm going to do the opposite operation of multiplying by 0.4, which is dividing by 0.4. So 50 divided by 0.4 is 125. So this is 100, this is 110, 120. So my next point is going to be right here. Okay, and I did my third here. Let's make sure we write that down, 3.2. Okay, now a lot of times you're going to be given the equation and you're going to have to create your own table. It's not going to be given there for you. So just remember, when you see an exponential equation, you're ready to graph it, go ahead and plot. So now we're going to make that smooth curve. And remember, there's an asymptote, which means that my curve will never go below the x-axis. If there was a +5, then it would never go below 5. If there was a -2, it'd never go below -2. So that asymptote is if there's a constant over here. There's not in this case, so that means +0, which means it's going to even out there. It's never going to quite touch 0. Okay, let's go ahead and look at our next one. This one had a 0.4, and so that was a number between 0 and 1, so we know it's a decay. This one has a multiplier of 3, and 3 is greater than 1, so we know it's going to be a growth. So once again, our 0 is 2. I'm also going to have my backwards one, so we're going to go ahead and plot 2 on our x-axis, and then we're going to go ahead and move my multiplier, times 3. 2 times 3 is 6. So we have the 0.16. Times 3 is 18. So we have the 0.218. So that's times 3. That's going to be 18. And then we have 18 times 3. Let me just make sure we get that right by using my calculator. 8 times 3 is 54. So we have the point 3, 20, 30. It's going to be like all the way up here on my other graph. So I kind of mentally just know that after this point, it gets really steep. I'm going to go ahead backwards, and 2 divided by 3 is 2/3. So I'm going to have -1 2/3. And once again, same situation, that's not going to go below the axis. So we're going to make a smooth curve that doesn't go below the x-axis, and we know it's going to get really steep after this point. And this is our exponential curve, y equals 2 times 3 to the x power.